Hello everyone, welcome to the playlist of Basic Electrical Engineering. In this session I will be discussing analysis of AC circuit with pure resistance. First of all, you know what is resistance. I have already explained the importance of resistance in the DC circuit. Now let us understand the importance of resistance in the AC circuit. What is going to happen if a resistor that is connected to the AC supply? You should know that resistance is a passive element. What is the meaning of passive element? Actually, it do not produce or consume any electrical energy, but it can convert electrical energy into heat. So resistors are categorized into the passive component. It is not an active component. First of all, you need to consider an AC circuit which is connected to AC circuit, which is connected to pure resistive circuit. So we have AC supply. It is a sinusoidal quantity, so we can, it's a function of time, so we can represent V of t is equal to Vm sin omega t. What is Vm? Vm is the peak value where omega is known as angular frequency. Then current flowing through the resistor is IR and voltage drop across the resistor is VR. So these are the basic information. You can represent it in this manner also. So we are applying a sinusoidal supply directly to a resistor. Okay, now we can able to say that the resistor is series with the particular supply. Okay, it's a resistor, we are going to provide the supply to the resistive load. Now look at the phasor representation. We need to recall the phasor representation. So here the as Vm sin omega t, V is equal to Vm sin omega t, where current can be represented as I is equal to Im sin omega t. Now tell me, is there any phase difference? No, because both are starting at origin. Magnitude will be different. Magnitude will be different, of course, but the phase difference phi will be 0. So in case of pure resistive circuit, both voltage and current are in the same phase. Now let the applied voltage in a circuit is given by V is equal to Vm sin theta, or theta can be written as omega t, where omega is known as angular frequency. Likewise, by applying Ohm's law, according to Ohm's law, current is equal to voltage by resistance. So do one thing, instead of what I can say, instead of Vm, okay, when I am going to write like I is equal to Im sin omega t, so instead of Im, you can replace it by Vm by R. So I can be modified as Vm by R into sin omega t. So very simple. So instead of Vm, you can I is equal to Im sin omega t. Let me rewrite it, so you'll understand. I is equal to Im sin omega t. Okay, Im sin omega t. So now what you are supposed to do is instead of Im, you can write it as I is equal to Im means Vm by R, Vm by R into sin omega t, sin omega t. This can be modified. Okay, I is equal to Vm by R into sin omega t. So in this context, we can able to say that magnitude will be different, but the phase difference, both are in the same phase. Both current and voltage, both are in the same phase. That observation you can able to make out. So we will be writing I is equal to Im sin omega t, and V can be written as Vm sin omega t. So this is actually the sinusoidal equation. V is equal to Vm sin theta or Vm sin omega t. Likewise, I is equal to Im sin theta or Im sin omega t. So comparing these two equations, we'll come to know that both are in same phase, in phase. So both current and voltage are in same phase in case of AC circuit with the pure resistance. So if I look at the phasor diagram, the concept will be more clear. You know, phasor is a rotating vector. It will be rotating at an angular speed of omega, and the arrow B representing Vm, that means peak value of voltage, and arrow A representing peak value of voltage, and B representing the peak value of current. So now what you can do, you can extrapolate it. You can able to, if you extrapolate it, you will understand A representing voltage and B representing current. A is actually in red color and B is representing in green colored one. Okay. So the omega t, that is actually v is equal to Vm omega t, and I is equal to I omega t, or you can represent as theta. Theta also you can represent. Okay. Now if you extrapolate, you will understand, you will get the instantaneous value. It is very easy to identify the instantaneous value. One more important thing, both are in the same phase. Both the arrows, both are lying in the same plane. So Vm and Im, both are in the same phase. Or you can write V and I, both are in the same phase. Same thing, it is written over there. But the magnitude is different. Okay. So otherwise you can represent it in this fashion. So IR and VR, both are in the same phase. This is another way of representation. So what is the advantages of phasor? So we will understand very clearly that in a pure resistive circuit, both current and voltage in the same phase. Okay, there is no phase difference between current and voltage, but the magnitude, the amplitude will be differed. So this also represents the phase, both current and voltage in the same phase. So look at this voltage magnitude of peak value of VR. You can Vmax. This is your Vmax, and second point you can able to identify Imax. Okay. The thing is, the amplitude is different, but the phase, both are starting at 0 degree. The half cycle completes at 180 degree. The full cycle completes at 360 degree. So the phase difference phi is equal to 0. So this is another notation. Okay. So the phasor is very depicts, it merely depicts the representation of two quantities in a simple and easier manner. Now you need to calculate the power consumed by the resistive load. Okay, the instantaneous power you can able to calculate. How to calculate instantaneous power? Voltage multiplied by current. So voltage is equal to Vm sin omega t, current is equal to Im sin omega t. So multiply both. Vm Im into sin omega t into sin omega t is nothing but sin square omega t. Hope it is clear. Now what is sin square omega t? Sin square omega t can be written as sin square omega t. Sin square omega t can be written as, this is 2, right? 1 minus cos 2 omega t by 2. 1 minus cos 2 omega t by 2. This can be done. Okay, please modify. So when it modified, Vm Im into 1 minus cos 2 omega of 1 minus cos 2 omega t by 2. 2 can make it together because it's a constant term. So please split up using the commutative law. You can split up distributive law. So Vm Im by 2 into 1 minus Vm Im by 2 into cos 2 omega t. Okay, so it becomes Vm Im by 2 minus Vm Im by 2 into cos 2 omega t. There are two terms. It is very clear that in case of resistive circuit there are two terms when it writing in terms of power. The first part will be constant, where the second part will be fluctuating. So the power can be represented in this fashion. Here power is nothing but product of voltage and current, right? Product of voltage and current. You are able to get the positive value. P is equal to Vm Im sin square omega t. And here also current, what about the current? Current will be minus, negative. Voltage is also negative. Negative into negative means plus. You will be getting positive value. I hope it is clear. So anyway, instantaneous power will be Vm Im by 2. What about Vm Im by 2 into cos omega t? Yes, of course, that is going to get cancelled. See, same thing is representing the power, representation of power. Power is nothing but product of instantaneous voltage and current. So what about this term? I am asking the question that Vm Im by 2 into cos 2 omega t. How about this term? What happened? Yes, the answer is, for a complete cycle, the average value of fluctuating quantity Vm Im by 2 into cos 2 omega t, it's a fluctuating quantity, that will be 0. Therefore, the power for the complete cycle is Vm Im by 2. So Vm Im by 2 means what? How can I modify with Vm Im by 2? So Vm Im by 2 can be modified as Vm by root 2 into Im by root 2. What is Vm by root 2? Vm by root 2 means Vrms. RMS value. I already explained what is RMS quantity. Please refer the video. Im by 2 means IRMS. IRMS. Product of Vrms into IRMS, that is equal to the power P. Okay, so this you have to remember. Vrms into IRMS. So where V is the RMS value of applied voltage,